Good afternoon once again. I am going to talk about cloud technology. This is not the first time I'm addressing this at Racurs conferences. Previously, I used to reflect on whether or not they should be used, followed by some experiments. Now I'm going to talk about real projects from life where Photomode is used, or where it might be used in the future. Why are cloud technologies used in photogrammetry? Primarily, it's attributed to the growing number of volume. TMC3 has been marketed. We also do cities with large overlaps. So based on these chunks of data, new products are generated like 3D models that require heavy calculations and powerful computing capabilities. So the speed of internet is increasing, the rate is growing to upload it in the sky and then receive the results from the sky. If we look at photogrammetry, the previous speaker was absolutely right that you have to treat automation with caution. Anyway, any photogrammetric algorithm are fully automated. And here you can see building blocks that show either an algorithm or data, entry and exit. So if you piece together a chain with these building blocks, you press one button and you will get the final result. Occasionally we refer to the fact that there's not just Photomode but also Photomode conveyor that Racurs has. Dmitry Kochurgin will elaborate on this in more detail. So what's Photomode conveyor? This is an automated system. You let her know what kind of entry data you have, what operations need to be performed, and what you want to obtain at the end. So this technology can also be put up on cloud. No changes have occurred in Cloud EO. Photomode has been resident there for a year. GeoCloud will be talked about by Yuri Reisman in the next intervention. I'm going to focus instead on the cloud that should become operational in 6 months. The cloud, we and Innopolis Institute at Tatarstan have been jointly developing. So I will also talk about automated solutions within that block. So the first two cloud placements of Photomode could be described in a way that the supplier or the host offers you powerful capabilities. At Innopolis University there will be enough power, I mean about 1,000 cores, and you can quickly perform different tasks. I mean, I'll give you an example. We tested a cloud solution for Russian space system. If I'm not mistaken, in the fall, someone from Roscosmos came to us with a pilot idea, and it took 1 month from data preparation to obtaining final result. There was another case where 7 days, it took 7 days just for calculations, but they were not happy with that because they had something else in mind. So they came to us and they said, we have a cluster at the Russian space system So let's try out a cloud-based solution. So we had about 100 dedicated cores, and instead of a week's worth of calculation, it took just a couple of hours for the same amount of data to be processed. Following last year's roundtable, I was approached by a representative of one company, and he suggested using Chelyabinsk University as they have some supercomputers, but still we didn't get what we wanted, and I'll explain why. If we look at powerful photogrammetric data processing, there is a lot of tons of vector data and other data, and they have to be processed quickly. Those cores need to be provided with data fast. So there was no issues with the element on top, which is CPU cores. Data transfer aspects, I mean, as the number of cores grows, we might be confronted with the data transfer issues. But there is definitely a problem with the storage component. So if you have 100 and 140 CPU cores, to keep them busy, you need an SSD RAID massive and 20 gigabytes per second channels. As CPU cores numbers grow, this will not suffice. So what can you use instead of RAID massives? There is a system called CEPH or CEPH. It's a file system designed by Geneva-based Nuclear Research Center. This system operates quickly because it's deployed on a large number of computers, where each computer doesn't store a lot of data. There is a lot of data duplication, and you can hook up to the internet and obtain the data you need. So there is a good time to failure characteristic. A problem has arisen is that it was Linux-based system, and when we tried it, we had very slow speed on our hand. And even though Photomode is a Windows-based program, we immediately managed to increase the rate of production 3-4 times, as shown on the picture on the left. This is what we're efforting with Innopolis, and on the right you can see additional auto chains also developed by us jointly. The 6th chain repeats the Photomode conveyor. The first 5 are less sophisticated, like generating mosaic from satellite plus DTM, or the same with aerial photography or UAS, or with surface regeneration. For all of that, a web interface needs to be developed. Input and output data, and where you can expect the output data. If the result will be unsatisfactory, you can tweak the parameters and relaunch the system. When I talk about automation, I failed to mention one procedure that is not automated, which is stereo vectorization. And with stereo vectorization, we found a solution up on cloud. We have a server which generates a server picture. The left and right images are mixed in the proper way, then it is transformed, compressed, and transmitted over the special network of stereo clients. And then a client can draw objects of interest, even though in reality they are drawn in the cloud. You know, we have a production facility, and we were told you can't use it initially. But last month, they told us, well, it's kind of unusual, but I guess we can give it a go. So you can transfer data from Moscow, from Khabarovsk to Moscow. So they said it's not customary. It will take some getting used to, but I guess it will do. So the first version of stereo client should be up and running in December this month, and it will support the same hardware as PHOTOMOD. It's high-frequency monitors and goggles, or passive monitors. But theoretically, we will have to look into the market state of play. It's possible that in case of high-frequency monitor, at the moment at least, we're using special video cards, OpenGL buffering they use. But there are cheaper alternatives that are used for gaming.
And as long as the stereo image is now independently developed by the server, here you just need to put in the stereo card, quite an expensive one, a gamer's stereo card, which would be good enough for you, and a stereo will work. Well, it's not there yet, but we're almost there. Next, moving on to the passive or mirror stereo. One of the next presentations will be about such a stereo monitor developed in Germany. And these monitors, some of them are supported by stereo client, but in future what is more interesting, you won't need any special video card, just regular Intel would do, just a stereo client, and you will also have a stereo. And the very future of this, very future if you don't have money for this, there are smartphone add-ons which cost cents, nothing really, and you take a cell phone and you put in, you download a special app, connect Bluetooth mouse to it and connect it to the cloud, and you can draw. Previously, at previous conferences, they were given anaglyphic glasses. Now you can be given such cardboard boxes with simple lenses inside, so that all the users in this room can watch a real stereo. The whole project, not only the stereo but also automatic links here, is the spring of next year. All the people wishing to can work there, as long as cartography is getting together, and I think the stereo client can be installed in other clouds, GeoCloud, for instance. Now we're talking about testing this new stereo client in GeoCloud. I see certain interest there. Stereo clients can be multiple. There are different applications for that. Like, for instance, we were approached by a Hungarian company who supply their work to China and India, and they want to deliver their data. and they say, let us collect this data in Europe, and the operators will be drawing them in, say, India or China. And before the end of my presentation, I'd like to say that the forecast that cloud technologies will be growing by 15% per year are coming true. They will continue to grow. The volumes of data are growing as well. The red line on the diagram down there, and the cost of storage of this data is dropping. All of this contributes to introduction of cloud technologies both in geoinformatics and other sectors. Thank you very much. Let's get on with questions. And actually I invite you to the round table where we have plans to discuss it in greater detail. Questions?